problem 1 of the exam review, and we are given the S and R inputs for a gated SR latch, and we are supposed to say what the output is. So before we do that, let's remind ourselves of the different kinds of latches and flip-flops and what they do. And here we go. So we're going to look at the characteristic table of the different latches and flip-flops to remind ourselves of what they do. So the SR latch, the characteristic table shows us that, and we'll just look at QA. Q bar should just be the opposite of that. So if the S and R are both 0, there should be no change. If S is 0 and R is 1, that's a reset, and so Q should be 0. If S is 1 and R is 0, that's a set, and so Q should be 1. And for an SR latch, you want to avoid having both S and R 1, so that's forbidden, so don't do that. So that's an SR latch. Now a gated SR latch is like an SR latch, except it only works when the clock is 1. When the clock is 0, there's no change. So we also have the clock input. A gated D latch, with a D latch or a D flip-flop, the output Q follows the input. And so if you look at our characteristic tables, they're labeled, the last two we've done, they're labeled QT plus 1. That means what is Q, what is the next Q going to be? And it refers, Q of T refers back to the previous Q. So when the clock is 0, Q of T plus 1, the next Q is just what Q was before, so there's no change. And so that's what gated means. Now, other than that, Q is going to follow D. So when D is 0, Q becomes 0. When D is 1, Q becomes 1. And that only happens when the clock is 1, because it's gated. Now, a negative edge-triggered flip-flop, edge-triggered means that it can only change on the clock edge. So if we look back at our problem here, you have the positive clock edge and the negative clock edge. So the positive clock edge is when it goes from 0 to 1, and the negative clock edge is when it goes from 1 to 0. And when you have a negative edge-triggered flip-flop, it can only change at the instant that the clock changes. So once it makes its change, it's not going to change again throughout the whole clock cycle. So if you have a negative edge-triggered flip-flop, then it'll change at the first negative clock edge, and once it changes, it's going to stay the same until you get to the next negative clock edge. So whatever it is right here at the first negative clock edge, it's going to be that same all the way through. So that's how edge-triggered works. And a positive edge-triggered D flip-flop is similar, except it only changes on the positive edge. Now a T flip-flop is a flip-flop that is going to toggle the values. And so the next value of Q is going to be the opposite of what the last value of Q, or the complement of the last value of Q. So if T is 0, then the next value of Q is whatever the opposite is of the previous value. So if T is 0, forget that. That's only if T is 1. If T is 0, there's no change. So when T is 0, there's no change. The value of Q is Q of T plus 1 is exactly what Q of T was, no change. Only when T is 1 does it become the opposite of what it was before. So when T is 1, Q of T plus 1 will be the opposite of what it was before. So let's say Q was 0 and now T is 1. Well, the next Q will be 1 because the one before was 0, so it'll become 1. Let me see if I can show this a little better, because I know I'm not making sense. Okay, so let's say we have when t is 0 and q of t is 0, then q of t plus 1 is also 0 because there's no change. If t is 0 and q of t is 1, then q of t plus 1 will also be 1 because when t is 0 there's no change. When t is 1, we'll have a toggle. So when t is 1 and q of t, the previous value of t is 0, then the next value of q of t plus 1, will be 1. It'll be the complement of the previous value. And if t is 1 and q of t is 1, then the next value of q will be 0. So hope that makes it a little more clear. Okay, so that's a T flip-flop and a J. Oh, and it can be positive edge triggered or negative edge triggered, and you tell whether it's positive edge triggered or negative edge triggered by looking at the triangle. So if we look at just an average flip-flop here, let's see. Okay, sorry about that. Here we have our flip-flop, and we can tell it's a flip-flop because of the triangle. That triangle is telling us it's a flip-flop, and this is a positive edge flip-flop. If we had a little bubble here, then that would be a negative edge flip-flop. Now let's look at our latches. So our latches, a non-gated latch doesn't have anything, and a gated latch has a clock. So that's how you can tell the difference between a latch and a flip-flop. Okay, so now let's look at the JK flip-flop. The JK flip-flop is a lot like the SR latch, except 1-1 is an allowed state. So when both J and K are 0, the value of Q doesn't change. When K is 1 and J is 0, that's a reset, and the next value of Q will be 0. When J is 1 and K is 0, that's a set, so the next value of Q will be 1. And when they're both 1, then it's a toggle. So when it's both 1, it's like a 1 in a T flip-flop. It changes the value of the next value of Q to be the opposite of what the previous value of Q was. Okay, so let's go back now and look at our problem. So we have our clock, and we have our signals for S and R. And so what the clock is telling us that it's gated, and we want to see what the output is. So I like to draw little vertical lines that are going to tell me when I might make a change. Now since it's gated, it can only change while the clock is 1. So I'm putting little vertical lines wherever the clock changes from being 1 to being 0 or from being 0 to being 1. And I know that while the clock is 0, there can't be any change. But as long as the clock is 1, it can change. And that makes it different from a flip-flop, because a flip-flop is only going to change once during the entire clock cycle. Okay, so we are assuming that Q is initially 0 and the clock is 0. So now the clock is 1. So we'll look at the values of S and R. S is 1 and R is 0, and that corresponds to a set. So it'll be a set, and a set is 1, and it'll be that 1 all the way through that clock, that positive clock time, because there's no changes there. And then at the negative clock, at the 0 clock, it's also not going to change because it can only change when the clock is 1. So when the clock is 0, there's no change. But now when the clock is 1 again, we'll look and see what the values of S and R are, and the values of S and R here are both 0. And when they're both 0, that means no change. So we'll have no change. Wait, no, hold on, because there is a change during the clock cycle. So let's see. So there's no change until we get to here. But when we get to here, and the clock is still 1, so we can change, R becomes 1 and S is 0. When R is 1 and S is 0, that's a reset. So it will become 0. And it'll stay that way because there's no more change up here. And then during the negative clock, or the 0 clock, it will be no change. And then when we get to the clock being 1 here, let's see, we've got R is 1 and S is 0, so that's 0. But here we have a change, and we have S is 0 and R is 0, so that means no change. So it will continue like that, and it will continue through the 0 clock cycle without any change. And now in this clock cycle, let's see what happens. During this little part right here, S becomes 1. So it's no change, because they're both 0, until we get to that part. Here S becomes 1, that's a set, so Q will become 1. Now here's another change, but let's see what happens. S and R are both 0, and that means no change, so it'll stay at 1. And it'll stay at 1 all the way through there. And then we get to the next clock cycle, and we'll look and see what S and R are. S is 0 and R is 1, that's a reset, so it'll go down to 0. And you'll have that. So this would be the Q output for the gated SR latch.